I will start with the discussion on the homework. Has any of you have any problem with the homework? Apakah ada permasalahan terkait dengan PR-nya? Silakan jika ada yang merasa bermasalah dengan PR-nya. Any problem with the homework? Chai Sarendri. You have any problem with the homework?
Yeah, I think I have problem, but I think I got solved it. But I don't know the answer.
Oh, you haven't solved it yet.
I have solved it, but I'm afraid that the answer is wrong.
Which one?
For the number one.
Number one, this one also. Okay.
Yes.
Okay, thank you. Who else that have a problem? Number one. So there is one person having a problem with number one, and then number two. I'm not sure whether some of you have a problem with number two. Anyone here having a problem with number two? Muhammad Said? Hello, Said? Muhammad Said?
Yes, sir.
You have a problem with number two?
Just a bit, just figuring the, yeah.
So yes, okay. How about the other number then, Said?
I got it, but it takes time.
Okay, but it's okay if it takes time, but as long as you know how to solve it, it's supposed to be okay. Okay, but I think I will try to discuss everything, although I will not discuss it until we get the answer. So if we do it that way, I'm afraid that we will not be able to solve many problems. So as I told you in the frame, okay, actually the way to solve it is quite clear. We have a flow chart that you have to follow in order to solve it. So there is a steps that you can just follow in order to solve it. Okay, but sometimes it is harder. It is hard for us to find out to how say that for those who just learn about frame. Sometimes it's hard for you guys to determine whether it's two force member, multi-force member, and then how to get used to solve the problem in the frame. Okay, so I think I will start with number one. Okay, but wait a minute. Take the frame. Oh yeah, by the way, for you guys, right? If you try to take a look at my YouTube channel, right? There are several problem examples that I discussed there. So there are several problem example about frame that I discussed there. So you can try to go through to my YouTube video to find out about it. I believe there is one playlist for statics. Just try to find out the problem that actually you want to solve there, because I have solved so many problems there. Okay, we will start with this one. Say Chai Sarendri. Okay, which part that you are confused about for this one?
First time is about drawing the FPT.
The free body diagram. Okay. But first, before you draw the free body diagram, you have to understand the problem first. Okay. What is asked in this particular problem? Chai Sarendri. I'm not. How I supposed to address you? Do you have any nickname like that, Rendri? Randy.
You can please call me Randy.
Oh, Randy. Okay, Randy. What is us in this particular problem, Randy? Okay,
The
M.
value
Okay?
of M. So
Yeah, the value, the moment value necessary to lift the wheel. So the moment value necessary to lift the wheel, it's already shown here. The moment is counterclockwise, okay, and it's given at P. Okay, it's given at P like that. Okay. At P, yes, correct. And the MAO, okay, have a combined weight of 100 lb. So this particular arm has combined weight of 100 lb with center of gravity at G or here. So we're supposed to put the force there, 100 lbf at G downwards. Find the value of M necessary to lift the wheel. Okay, but first, can you analyze here? Is there any two force member in the problem, Randy? Do we have two force member in the problem? Hello, Randy?
I think no, sir.
No, are you sure? Try to
Yes.
take a look. Try to take a look. Two force member, right? If you are confused, if there is a member which only get the load at both ends only, okay, that particular member will be two force member. But remember, it's only a load, okay? If at one end it's given a moment there, so for example, if we have this kind of member, and at both ends we will get the load like this or like this. This one we can say that this particular member is two force member. But if at both ends one of it's given moment like this, it won't be a two force member. Okay, so can you see which member there is a two force member?
DO, sir.
DO is not two force member. DO is actually is not a member. So A, from A to O is actually a straight member like that, straight member, and it has a hole at D like this. Randy, okay, do you understand?
Yes, sir.
Okay. What one more thing, when okay at both ends it has pin on it without moment there and there is no friction there, okay, most likely that member will be two force member. Can you see a member which has pin joint at both ends without moment?
So it should be DC, sir.
Yes, correct. TC is two force member. So you have to remember, okay, wait a minute. When we discussed it before, I will just share screen here. Okay, let me see the frame, this one. Okay, you can see here that from the beginning, right? I already told you guys that in order to solve for frame, the first thing that you're supposed to do is to identify the two force member. Okay, correct, Randy? So you won't be able to solve it if that particular system has two force member, but you cannot identify the two force member. Jadi Kalau misalkan dari suatu sistem itu di frame, sistem frame itu ada batang dua gaya, harus diidentifikasi terlebih dahulu. Kalau tidak diidentifikasi terlebih dahulu, kita tidak akan bisa menyelesaikan. Bayang ya, Randy? Oke.
Kebayang, Bro.
So that's the thing, the first thing that we supposed to do here, to determine which part of it there is a two-force member. So in this case, CD is two-force member. When we know that CD is two-force member, what we supposed to do next, Randy?
Isolate the member.
Sorry?
Isolate the member.
Isolate, correct. After we know the two-force member, then isolate the member. Okay, isolate the remaining member. Okay, if we know that CD is two-force member, then the remaining member will be BC and AO, right? Andy, correct, right?
Yes.
Yep. That's the free body diagram that we're supposed to draw. Okay, but the things here, okay, I think I will start with AO because the one in question is moment here. And in order to find out moment, we have to know the force which is happening at the member DC. So after you know which one is two-force member, and after you isolate the member, then try to imagine the steps to solve it. Okay, try to imagine the steps to solve it. First, I will draw the member AO. Okay, something like this. What forces that we have here, Randy?
The weight, sir.
Weight at G, okay.
At G.
So yes, here. What is the value of the weight? 100 lbf, right?
Yes. Yes.
What else?
And then we have in force in A.
A, it's a pin joint, so we have what?
AX and
AY,
AY.
correct? AY, AX. What else?
And also in D.
At
Yeah.
D, okay. Yeah. At D, okay. Remember, CD is two-force member. So at D, we know the direction of the force, right, Randy?
Yes, sir.
So as usual, I always try to assume that it's always under tension for two-force member. Okay. So we do it this way. And I name it as FCD. Okay, Randy?
Yes, sir.
Yeah. This is one of the free body diagram, AO. Okay. Can we solve this, Randy?
I think yes, we can.
Yes, we can, because we have, for this particular free body diagram, okay, the first free body diagram, we have sigma fx1 equal to 0, sigma fx2 equal to 0, and sigma moment, why it's 2? Sigma fy1, 1 here means it's correlated with the first free body diagram, and sigma moment 1 equal to 0. Okay, we have three equations: sigma fx, sigma fy, and sigma moment. Okay, in order to solve for this, we can solve it. But the problem is, in order to get the one in question is just the moment, right, Randy?
Yes, sir.
Okay, do we have to solve for ax and ay?
I think for the moment we are get for the FDC, so we don't need to find the fx and fy.
Yeah, we don't need to find the ax and ay. So basically, for this particular problem, okay, basically you don't have to solve using this and this. What you need to do is just using this particular equation, sigma moment at A equal to 0, right? By doing so, you will be able to find FCD. Correct or not, Randy?
Yes, sir.
Yeah, because by using sigma moment at A equal to 0, because the center of rotation is at A, the moment arm of AX and AY will be 0. There will be no moment which is caused by AX and AY. Okay, so that particular equation will only consist of FCD and 100 lbf with the moment arm. Because of that, you will be able to solve for FCD just using that particular equation. So actually, we just need to solve this one equation in this particular free body diagram, because based on the question, we don't have to solve for AX and AY. Okay, until this point, anyone want to ask question? I will not solve it, because my main aim right now is you understand the steps to solve it. Okay, you understand the steps to solve it. How to solve it is just mathematical. So it's mathematical problem. Now become mathematical problem. But the steps to solve it, you have to get used to it. Of course, when you practice, try to solve it until the end. Okay. Any question? Yeah. Wait a minute. Zakia, apakah ada pertanyaan?
Enggak, Pak.
Aman ya? Sip. Fauzan Ahmad.
Yes, sir.
Should be okay, right?
Yes.
Okay, good.
Understood.
Now, still Randy. After we solve this, in order to find out the moment M, which free body diagram, which multi-force member that we have to solve, Randy?
I think for only PC.
PC, correct. Okay. So basically, from the first free body diagram, our main purpose is to find out FCD, the force which is happening at the two force member CD. Then, after that, we go to the member BC. Okay, we go to the member BC. Okay, now let's draw the free body diagram of member BC. Something like that. Okay, just now I assume the FCD is under tension. Okay, if the value most likely is under tension, yes. So if the value is positive later, so it's supposed to be still under tension. So FCD will be going this way. Correct, right, Randy?
Yes.
Because it's under tension. Then what else that we have here?
Moment at B, BX and BY.
BX, BY, moment at B as well. Okay, so we have three, right? BY, BX and MB. Okay, now do we have to solve for the reaction force BX, BY? Randy, do we have to solve BX and BY? Do the reaction forces at B is the one that we have to solve in the problem? No, it's not us, right?
Just only the moment. Right?
Yep. So in that case, we don't have to solve for BX and BY. Okay, now using the second free body diagram, how many equations that we have? How many equilibrium equations that we have?
Only one, sir.
Why one? We have three actually, okay?
Oh, yeah, wait.
But at the end, if you just use one, it's supposed to be okay. Okay, sigma fx2 equal to 0, sigma fy2 equal to 0, and sigma moment 2 equal to 0. Okay, but remember, bx and by is not in question, so we don't have to solve it. Kita tidak perlu menyelesaikan yang tidak ditanyakan, ya. Jadi yang ditanyakan di sini hanya moment saja. So the one that is in question is just the moment, MB. In that case, we can just use the third equation. Just use sigma moment at which point, Randy?
Yes, sir.
Yeah, sigma moment at which point in order to solve for
At
moment B.
At B.
At
Moment at
B, correct. In order to nullify for Px and Py, right? If we use sigma moment at B, okay, Px and Py, the moment due to Px and Py will be 0, right? So we don't have to the equation later will only consist of MB and FCD. And remember, we have the value of FCD already because we already solved for the first free body diagram. Okay, in this problem, can we solve from MB or not, Randy?
Yes, sir.
Yeah.
MB.
So you can imagine, right, Randy, how important to find out about the two force member, right, Randy? I
Yeah, of
believe
course.
you got you cannot solve this particular problem before because you don't know that CD is two force member, right?
Yeah,
Yeah.
correct, sir.
That's the main problem. So I told you guys, okay, for everyone here, the first thing that is supposed to try to get whenever we try to solve for the frame problem, try to determine which member is two force member. Okay. Then after that, the next step is to isolate the non-two force member, the multi-force member. In this case, we have AO and BC. Okay. But the two force member, because it's two force member, we know the direction of the force. Okay. We replace the two force member with a force in the same direction as the member, like this. That's the way to solve it. Okay, do you get it, right, Randy?
Yes, sir.
Good.
Thank you.
Now let's go to the second problem. Okay, I will go for it one by one, but at faster speed. Okay, still Randy, because before you have a problem with determining a two force member. Still Randy, can you see in this particular member, without looking at the problem, but can you see, is there any two force member in this particular problem, right?
Yes, sir. AC.
AC? AC? AC?
EC.
EC is not two force member. Actually, this one, okay, ECF, okay, ECF, you can see here, it's one long member, Randy. So you can see, right? There is pin here, there is pin here, and there is pin in the middle as well. So it's not two force member, eh? Okay. What I told you about two force member, Randy?
The member without moment.
No, not the member without the moment. Okay. It's a member where the force only happening at both ends. So if there is a pin, the pin only happening, the pin is only there at the both ends only. So if you have this kind of member, right, with the pin inside of the pin at the middle of it, this kind of member is not two force member, but this member is two force member. And one more thing is, okay, the pin is supposed to be frictionless, and there's not supposed to be any moment at the ends as well, and at the middle as well. Based on that description, can you see which part of it there is the two force member?
So it should be AB.
AB, correct. That's simple. AB. What else? There is one more.
CD.
CD. Yes, correct. You can see clearly, right now?
Yes, sir. Thank you.
So the pin only happening at both ends. The pin is only there at both ends. Jadi untuk membedakan antara batang 2 gaya dengan batang multi gaya itu gampang, ya. Kalau misalkan ada batang pinnya itu hanya ada di ujung-ujung saja, kemungkinan besar dia batang 2 gaya. Tapi perlu dilihat juga apakah pinnya itu frictionless atau tidak. Kalau tidak ada gesekan di sana, frictionless, artinya dia bisa jadi batang 2 gaya. Kalau tidak ada momen di ujung-ujungnya, dia batang 2 gaya. Seperti itu. Itu persyaratannya gampang. Nah, kalau misalkan ada pin di tengah-tengah, berarti kan gayanya tidak hanya di ujung-ujung saja. Ini bukan batang 2 gaya, ini batang multi gaya. ECF di situ, itu ada pin di tengah-tengah. Dia bukan batang 2 gaya. AB pinnya hanya di ujung-ujung saja dan tidak ada gesekan di pin. Oke, tidak ada momen di pin, hanya gaya saja. Itu batang 2 gaya. CD pinnya hanya di ujung-ujung saja, tidak ada gesekan di pin. Ya, tidak ada gesekan di pin dan tidak ada momen juga di ujung-ujungnya. Itu batang 2 gaya. Ya. That's the first thing that we supposed to do. Okay, determining the two force member. Determining the two force member. So the first thing first, determining the two force member. So we know already that AB is two force member, CD is two force member. Oke, Zakia, dimengerti ya?
Iya, Pak.
Oke, sekarang saya minta bantuannya ke Zakia. Supaya ini AB batang 2 gaya, CD batang 2 gaya. Dari permasalahan yang ada di sini, yang ditanyakan apa Zakia?
Force-nya AB sama CD.
Yang ditanyakan adalah gaya yang terjadi pada AB dan CD, dan juga apa? Ada lagi tuh.
Resultan.
Resultan di pin
E sama F.
E dan F. Ya, itu yang ditanyakan. Jadi saat yang ditanyakan hanya itu saja, fokusnya hanya menjawab yang ditanyakan. Jangan menjawab yang tidak ditanyakan, karena kalian akan harus menyelesaikan persamaan lebih banyak. Oke? Kalau untuk statika, ya pragmatis saja. Yang ditanyakan apa, yang jawab itu. Oke? Nah, kemudian yang diketahui di sini apa, Zakia? Masanya, batangnya bermassa atau tidak? Tidak ada tulisannya.
Batangnya enggak.
Yeah. Okay. So this is for everyone. If it's not written there that the member has mass like that, it means that it's massless member. We can assume it as massless member. So this is one of the problem where we can assume that all the members there is massless member, which means that it has no mass. Okay, we can assume it that way. Okay, the one that is known from the problem here is the mass. The supported mass is 500 kilogram, and the center of gravity is at G. Okay, jadi diketahui di sana massa dari bucketnya itu beserta bebannya adalah 500 kilo ya, Zakia ya. Di COG-nya di G ya, gitu ya Zakia?
Iya, Pak.
Oke. Nah, sekarang untuk menyelesaikan ini, apa dulu yang harus kita kerjakan, Zakia?
Ngitung W-nya.
Ngitung W ya, 500 kali G ya. Jadi 5.000 harusnya pakai 9,81 kalau di ujian ya. Cuman kalau sama saya biar gampang di sini pakai 5.000 Newton aja langsung. Oke. Nah, batang 2 gaya yang tadi yang sudah diketahui adalah AB dan CD. Kalau kita sudah tahu batang 2 gaya AB dan CD, sisanya jadi batang multi gaya ya. Oke, step pertama adalah menentukan batang 2 gaya. Step kedua adalah mengisolasi batang-batang multi gaya. Nah, untuk menyelesaikan permasalahan yang ada, mana dulu yang harus kita solve? Mana dulu yang kita harus selesaikan, Zakia?
Cari momen, bukan, Pak?
Nyari momen di mana? Enggak, maksudnya free body diagram mana yang harus digambar dulu? Kan dipisah-pisah kan ya pasti?
Yang ada masanya.
Yang ada masanya ya. Berarti ini aja ya, si bucketnya doang dulu ya.
Iya, Pak.
Oke, kita coba gambarkan bucketnya. Oke, kita gambarkan di situ. Gaya-gaya bekerja apa saja, Zakia?
Ada EX, EY.
AXAY, EXAY, betul sekali, betul ya. Ada pin di sana ya. Ini ada EX, EY, apa lagi?
Ada FAB.
FAB, betul sekali, FAB. Biar gampang, asumsikan tarik dulu ya. FAB. Lalu ada apa lagi?
Ada W.
W, di G ya, sip. Di sini ada WW besarnya, kita langsung pakai 5.000 aja ya. Nah, yang ditanyakan di situ pin E ditanyakan, gaya-gaya di pin E, FAB ditanyakan. Berarti semuanya harus di-solve ya, Zak ya?
Iya, Pak.
Oke, semuanya di sini harus di-solve. Selain itu juga untuk mengerjakan yang selanjutnya, kita terpaksa harus men-solve semuanya yang ada di sini juga. Oke. Nah, kita punya EX, EY, FAB. Persamaan yang kita punya apa?
Sigma momen sama dengan 0, sigma fx sama dengan 0.
Oke.
Sigma fy sama dengan 0.
Sama. Kita punya 3 persamaan. Berapa unknowns di sana?
Ada
3 juga ya?
Iya.
Bisa diselesaikan harusnya. Betul ya?
Iya.
Sip. Ini kelihatannya untuk yang masalah ini, yang nomor 2 ini kamu tidak ada masalah ya, Zaki?
Iya, Pak.
Oke, sip. Kamu ada masalah di nomor berapa?
Nomor 4, Pak.
Nomor 4. Oke, ya udah, sip. Yang tadi yang bermasalah di nomor 2 tadi siapa ya? Who got the problem in number 2 here? Fauzan?
No, saya Pak.
Just know who have a problem with number 2. If I'm not mistaken, one of you have a problem with number 2. Who was it just now? Oh, Nabil. Oh, Nabil. Nabil, do you have a problem with number 2, Nabil?
Oh, I think I'm good, sir.
You're good. Okay. Randy, tadi yang bermasalah di nomor 2 tadi siapa ya, Randy? Who got problem with number 2, Randy?
Kalau nggak salah, Zahid nggak salah.
Zahid.
Iya.
Zahid, halo Zahid. Do you have problem with number 2, Zahid?
Not that much.
Not that much. Okay, but it's okay.
Yeah, it's
I
okay.
just want you to know about it. You understand, right? That number 2 here in the number 2. Wait a minute. Let me stand a bit. Okay, sorry guys. Okay, I think I will give the class while standing. I have a big problem with my back, lower back. So it's quite bothering me. Okay. Zahid, do you understand that A, B, and C, D is 2 force member?
Yes, sir.
Okay, good. Do you know about this as well, right? The first free body diagram, how to solve for FAB, EX, EY. You understand about that as well, right?
Yes.
Okay. After we solve for this, what is our next step?
After that, I use the request.
Which free body diagram that we're supposed to draw?
I used the F1 after that.
F1. What is F1?
The F free body diagram to calculate the rest.
Everybody. What do you mean by that?
No, oh, I'm sorry. What's that?
Okay. After we solve for this, okay,
Yes.
which means that we solve for FAB, EX, and EY.
Yes.
What is our next step? Which free body diagram?
Resultant.
Yeah, which free body diagram that we're supposed to solve?
The C1.
C. What C?
You mean the next free body diagram
Yeah.
to be a
So, okay, remember, right? Our first step is to determine which one of it is two force member. Okay, we done it. A, B, and C, D are two force member, and then after that we have to isolate the multi-force member. We know already from Zakia, we know already that this bucket is multi-force member. Okay, which other member that is actually supposed to be multi-force member, and we have to solve it to get for the FCD and
oh no, ECF.
That's my question. ECF, yes. So that is our next free body diagram, right?
Yes.
Say. Hello, say.
Yes.
Yeah. Okay, that's our next free body diagram. Okay, so I think I will draw it here. This one is ECF. Okay, what forces that we have there? Say.
The weight of the. Oh wait.
The weight of what?
The mass.
We don't have mass here. It's massless, right?
No, the force from the previous one on the E.
Yes, correct. So EX and EY, we have to put it there because there is a
Yes.
pin at E there. And if EX is going to the, I think I made a mistake here. It's most likely it's supposed to be going to the left. EX is supposed to be going to the left, right? If EX is going to the left there, in the first free body diagram, in the second free body diagram, EX is supposed to be going where?
Left also.
Left also? Are you sure about that? Remember about action.
Oh yeah, yeah,
And
it's right.
Reaction.
Reaction.
So if in the first free body diagram is going to the left, the result is going to the left. In the second free body diagram, is supposed to be going where?
To the right.
To the right. Okay. EX. What else? EY, it's going up there in the first free body diagrams. In the second free body diagram, it's supposed to be going
Down.
down. Okay, what else that we have? FAB is under tension. So here, there is FAB as well, right? At point B, right?
Yes.
So if it's under tension, it's supposed to be going to the left or right?
Left.
Left, correct. This one is FAB. Okay, what else that we have there? Supposed to be joined. There is a pin C here and
Yes.
pin F, right?
Yep.
At F there, it's a pin joint. So we're supposed to have what?
FY and FX.
Correct. So we have FY, FX. Okay. At C,
We FCD.
FCD, correct, because it's a two force member. So assume it's under tension as usual. FCD. Okay. If we solve the first free body diagram, okay, if we solve the first free body diagram, this one, okay, the second free body diagram, in the second free body diagram, we already got the value of FAB, EX, and EY, correct, right?
Correct.
Yeah. So basically here, we just need to solve for FCD fx and fy. Okay, so we have three unknowns from the second free body diagram. And how many equations that we have in the second free body diagram?
Sorry, sir. What?
How many equations that we have? How many equilibrium equations that we have in the second free body diagram?
3.
So can we solve for FCD, fx, fy?
Yes.
Yes, we can. So that's the way to solve this. Okay, but as usual, the main core of the problem is determining the two force members. So you can see that determining two force member is very important. Okay, Said?
Okay, sir.
Okay, good. Okay, that's the way to solve the number 2. Now we go for number 3. Anyone here having a problem with number 3? Anyone? Fauzan, do you have a problem with number 3, Fauzan?
No, sir.
Okay, good. So basically, but I think I will just discuss it for a bit. Basically, the question in number 3 is if we give 80 Newton squeeze force at the handle of the pliers, okay, what is the force applied to the round rod here? So how to handle this is you can either solve the upper part or the lower part of the pliers. So if I just draw the lower part like this, okay, so this is the lower part, this part. This is the things that I draw. Okay. The forces there is supposed to be 80 Newton going down here. Okay, because of this, right? And beside that, at A, there will be pin. There is a pin at A. So at A, there will be AX and AY. And there is a normal force due to the rod like that. Okay, so basically it's very simple. And if we analyze this, okay, there is no two force member. So basically we only have two multi-force member. So this one, this is our first multi-force member. And the second one is this one. This is our second multi-force member. But luckily for us, it's symmetrical. It's symmetrical. So the upper part and the lower part is symmetrical. So because of that, we can only we can solve the problem just by solving one of the part. So drawing one of the free body diagram is supposed to be enough. So A is here. Because there is a pin at A, there will be a AY, AX. Okay, and beside that, because there is a rod there, normal force from the rod, there will be a normal force here, and that one is the one in question. Okay, that one is the one in question, and AX, AY, AX, AY is in question as well. So those three are in question. But remember, here, using this free body diagram, we have three unknowns, and AX, AY. Okay, we have three unknowns, and AX, AY. Okay, and at the same time, we will have three equations as well. Sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Okay, using sigma moment at A, you will be able to get N. Using sigma fx, you will be able to get AX. Using sigma y, sigma fy, you will get AY. As simple as that. That's number 3. Okay. Any question about number 3 before I move to the number 4? So basically, the the idea about frame and machine is actually all already given to you guys. The problem right now is practicing and practicing. Okay, with more exercise, I believe you will get better understanding at the frame and machine. Okay, but the main idea is always like that. Determine first, try to analyze which part of it there is two force member, then isolate the multi-force member and solve using the equilibrium equation. Okay, let's go for number 4. Okay, for number 4, there are some of you that have a problem here. Zakia, permasalahannya di mana, Zakia?
Ini tuh harus dicari semuanya nggak buat nemuin BG sama CG-nya?
All two force member of the loaded truss are of the same length. Member BCD is rigid beam. Determine the forces in the member BG, CG in terms of load L. BG, so this one is in question. CG. Okay. Kita coba dulu ya, apakah perlu diselesaikan semuanya atau tidak. Oke. Untuk menyelesaikan masalah ini kita bisa kombinasi menggunakan join method. Kita bisa kalau section method agak susah karena section method itu di sini nggak ada tempat untuk bisa memotongnya. Jadi lebih cenderung kombinasi antara join method dan juga menyelesaikan free body diagramnya. Oke. Nah, yang ditanyakan adalah BG, CG. Oke. Cuman kalau misalkan kita langsung selesaikan di pin G, itu tidak akan bisa beres karena di situ ada 4 gaya di sana. Oke, jadi tidak bisa langsung diselesaikan di sana. Nah, yang kita bisa lakukan, kita merunut dari kanan atau dari kiri. Jadi kelihatannya yang pertama kali harus dilakukan adalah free body diagram secara keseluruhan. Oke, free body diagram secara keseluruhan. Jadi kadang-kadang kita harus menyelesaikan permasalahan itu tidak langsung diisolasi, tetapi diselesaikan secara keseluruhan terlebih dahulu. Tergantung kasusnya. Untuk kasus ini seperti itu. Kita coba Kita coba buat free body diagram secara keseluruhan. Jadi seperti ini. Ini free body diagram secara keseluruhan. Di sini ada AY, AX, dan juga EY, plus ada gaya L bawah. Oke, harusnya dari sini AY, AX, EY bisa didapatkan kan ya, Zakia?
Iya, Pak.
Oke, kita bisa dapatkan AY, AX, EY dalam L. Itu kita bisa dapatkan. Nah, setelah AY, AX, EY kita bisa dapatkan, itu kita bisa coba solve titik-titik yang kita bisa solve. Oke. Nah, untuk menyelesaikan yang ditanyakan adalah BG dan CG. Oke. Ini kelihatannya akan lebih mudah untuk kita bisa menyelesaikan tanpa menyelesaikan BCD, karena BCD itu ada beberapa gaya di situ. 1, 2, 3, 4, 5. Jadi lebih gampang kalau kita runut dari bawah. Oke. Nah, setelah EY kita dapatkan, kita bisa selesaikan titik E untuk mendapatkan untuk mendapatkan titik E untuk mendapatkan ED dan EF. Oke, kita selesaikan titik E. Pakai metode join. Jadi nanti ada sigma fx sama sigma fy. Ada 2 persamaan ya, sigma fx sama dengan 0, sigma fy sama dengan 0, untuk menyelesaikan DE dan juga FE. Kita juga bisa, setelah itu, kita bisa selesaikan dari titik A untuk mendapatkan AB dan juga AG. Oke. Nah, selanjutnya kita coba selesaikan titik F untuk bisa mendapatkan C, F, dan juga GF. Seperti itu. Nah, selanjutnya terakhir kita selesaikan titik G untuk mendapatkan BC dan juga CG. Memang jadinya kita dapat semuanya ya, Zakia ya. Kita dapat semua gaya batang-batang dua gayanya. Oke, tidak ada cara yang lebih gampang daripada itu. Oke, Zakia.
Oke, Pak.
Okay, for this particular problem, is there any question? So, like it or not, I believe for this particular problem, we have to solve all the two force member in order to solve for BG and CG. Okay. Now I want to practice more. We still have 1 more hour. Frame exercise. Okay, this one we already try to solve it. This one is your homework. We solved this already. This one later. There are several problem example that we can go for. Okay, I think I will go for the others. Frame exercise. This one. Okay. This one is just like a short. This one is actually not that hard, and I just want to check with you guys, okay, whether you understand the concept of two force member or not. If we take a look at this, can you find out the two force member? Zahid? Hello, Zahid? Can you find out which one is the two force member, Zahid? Hello, Zahid? Hello, hello, hello. Zahid, are you there? I believe Zahid is not around. Neila, Fatia. Hello, Neila. Hello, Neila. Huh? Not around as well? In that case, Amadea then. Amadea, Naura Leza. Hello, Amadea.
Yes, sir.
Okay, Amadea. This one I will not discuss it in detail, but I just want to check whether can you determine which member is two force member.
Is it BF?
BF is not two force member. Remember, right? Two force member. The force is only happening at both ends. BF is a long member, and there is pin at both ends, but there is not a pin at the middle. So there will be load in the middle. So BF is not two force member.
Can a two force member be part of a long member?
Part of long member? What do you mean by that?
Yeah, for instance, like AB, it's part of AD, right? But then the two force member is only from A
No,
to B.
AD here is not two force member as well, because there is a force here, here in the middle. So two force member, okay? The main idea of two force member is the force is only happening at both ends. But two force member is not always straight. Can you find out which one of it is two force member?
Oh, then CE.
Yes, CE is two force member. So basically, if you draw CE like this, like now, or if you draw CE straight like this, okay, the forces will be the same. Okay, so if we draw CE, right, it is actually two force member. Why it's two force member? Because the force is only happening at both ends. And there is no moment at both ends. And there is no friction at both ends. So it's two force member. And if you ask me, in that case, how can we draw the direction of the force? What do you think? What is the direction of the force here? What is the direction of the force of the two force member, this particular member? Hello? Amadia?
It should be parallel, right, sir? The two forces.
Parallel with two forces? What do you mean by that?
No, I mean the two forces should be parallel with each other, right?
Yeah, supposed to be in the same line of action, of course.
So is it like this?
That's correct. It's supposed to be straight line. Correct. So basically, if we have this, okay, it's supposed to be like this. So that's the line of action of the FCE. Okay, from one end to the other end. You just need to create a straight line from one end to the other line. Okay, so good, Amadia. So if it's under under compression, it's supposed to be like that. So just like what Amadia drew just now, it's if the member is under it's the member under compression. If the member is under tension, it's supposed to be the other way around. Okay, good, Amadia. Okay, so this is it. Okay. Okay, this is actually, I think I can just discuss it a little bit. Okay, so in order to solve for this, we need to solve for the whole free body diagram first. Okay, after we solve for the whole free body diagram, in order to get for ax, ay, dy, dx, okay, yeah, then after that we can go for the single multi-force member. We have two multi-force member here, AD and BF. Okay, as usual, we have to know about all the tension force. Okay, that's why we have to solve for the pulley as well. Okay, then we know that the CE is two force member. That's why we don't have to solve for that actually, as long as we know the line of action. So we don't have to draw it like this. Okay, we can just do it straightforward by doing the line of action of CE using this particular direction. Okay. Then after that, solve for AD and what is this? BF. Okay. Those two are multi-force member. By solving for those two, we can solve for everything. Okay. This is another example. Still, Amadia. Amadia, can you find the two force member here, Amadia? Hello, Amadia?
Is it BC?
BC, correct. BC, it's two first member as well because the pin is happening and the pin is there at both ends. That's one thing. There is no friction there. There is no moment there at both ends. So BC is the first member. So basically, for this particular case, okay, the multi-force member that we have to solve is only AB, member AB only. And if we want to draw the free body diagram, it will be like this. Okay, still Amadia. Can you help me to draw all the forces which is happening at AB, Amadia?
Okay, there should be an upward force, AY.
AY, what else?
AX to the right.
AX, what else?
Weight is at the top right, 5.
Yeah, 5 kilonewton, correct?
Yeah, 5 kilonewton. And then
Wait a minute, there is a problem here. Okay, how about FB?
there should be a downward force.
Okay, at B there is supposed to be a force, but remember BC is two force member, right?
Oh, so it's at an angle.
Yes. So the angle is supposed to be just like this, 45 degrees. So from point B to point C, in this case, is 45 degrees. Huh? So if I assume BC is tension, it's supposed to be like this, FBC. Do you get it?
Yes, yes.
Yeah. So it's 45 degrees like that, because it's two force member. Okay. If you look at this, Amadia, how many unknowns that we have?
3 unknowns.
3 unknowns, and we have 3 equations as well. So we can solve this, right? Yep. Okay. This one we already tried to solve it just now as your homework. Okay. This one will be your homework. Okay. Wait a minute. Some of it will be part of your homework, but I think I will discuss some of it. Okay. Yeah. Let's discuss about this. Okay, for this one, I will call for Fauzan. Hello, Fauzan.
Yes, sir.
Okay, Fauzan, try to read the problem and try to understand the problem first. What is asked there in the problem? Hello, Fauzan. What is asked
Yes.
there in the problem?
The force in member AB.
Okay, the force in member AB, right? This one. Okay, and if you take a look at the problem, is it symmetrical or not, Fauzan?
Yes, it is.
Okay, it's symmetrical. So actually, we can solve this just by solving one of the sides. Okay, wait a minute. Okay. So it's symmetrical, and we know that the one that is in question is AB. Okay, and now Fauzan, can you help me to determine which member here there is two force member?
CE and ED.
Sorry.
CE and ED.
Okay, CE. CE is two force member. ED is two force member. What else?
AB.
AB. Anything else? That's all.
Yeah, that's all.
Yeah. So those three members are two force members. So we know that the forces happening at those members is in the same line as the member direction itself. Okay. Okay. Beside those members, then the rest will be multi-force member. Now, in order to solve this, where are we supposed to start? Which free body diagram that we're supposed to solve first?
Maybe the whole thing. So
The what?
the whole thing.
The whole thing. Okay, the whole thing. The whole thing. So if you draw the whole thing, it's supposed to be like this. Yeah, somewhat like this. And what forces that we have there?
Tension on the rope and then
on
the
rope.
weight
Okay. What else?
at 100 pounds of weight.
Okay, so it 800 lbf, right?
Yes.
Using sigma fx equal to 0, we can easily find the t, right? So t is supposed to be 800 lbf, right? What was that?
Yes.
Yeah. Okay. Next, after finding t, okay. After finding t, what we will get? What we supposed to solve?
We use join method to solve for each member.
Each member. So, which one that you want to solve first?
ED.
Huh?
ED. Member ED.
Okay, ED and CE. Yeah. Okay. So, in order to solve this, we have to solve for pin E, right? So, if we take a look at pin E there will be tension going up, and there will be a force due to member ED, and then force due to member CE. Correct, right?
Yes.
Yeah. Tension here is equal to 800 L. Yes. Okay. Using sigma fx, because it's a equilibrium at the point, we only have two equations: sigma fx equal to 0 and sigma fy equal to 0. Can we solve for this?
Yes.
Yeah, we can solve for FED and FCE, correct? Okay, the next thing that we have to solve, which one? Hello, Fauzan?
Maybe the force on the box. Like,
Okay, correct. The force on the box. Yes, you are good. Okay, the force on the box. If the box is like this, we have 800 lbf. Okay. What else that we have here?
FD and FG. No,
F what?
maybe the reaction from F and G.
Okay, you mean at point F and point G, right?
Yes.
So there's supposed to be, okay, there's supposed to be normal force due to the tongues, okay? The normal force, this is NG, this is NF, okay? Beside normal force, because the tongues, in order to leave the box, okay, it will it will need the friction, right? It will need friction force in order to lift the weight, right? So it's supposed to be a friction as well there. So friction F and friction G. Okay. If this one is exactly in the middle, using sigma moment in the middle, in the center, equal to 0, what we will get is FF will be equal to FG. Okay, and using sigma Fy equal to 0, what we will get is FF plus FG is equal to 800 lbf. That's why, because this one is same to each other, we will get FF is equal to 400 lbf and FG 400 lbf. Do you get it, Fauzan?
Yes, sir.
So we got FF, we got FG. Okay. How about the normal force? The normal force we cannot get it, but we know that NF using sigma Fx equal to 0. We know that NF will be equal to NG. That's all that we get. Okay, but at least we solve for FF and FG. Then after solving for CE, ED, and then the friction force, okay. Now can we solve for link AB then?
Yes, I think.
Okay, which free body diagram that we're supposed to draw?
CBG or DAF.
Yeah, it's up to you. Okay, so it's up to you guys. Okay, it's up to you guys. You can use the DAF or you can use the CBG. So it's up to you guys. Either of those can be used to solve for the problem, but we will use only one of it. Okay, CBG. Okay, hey, yeah. I haven't put the additional slide there. Sorry, I think I need to wait a minute. My battery, my laptop battery is running out. Okay. So now I want to draw for CBG. Okay, CBG is like this, roughly like this. Yep. Yep. What forces that we have there, Fauzan?
FCE and then
FCE in the direction of the member. FCE. What else?
FG and NG.
FG and NG. FG is supposed to be going downwards or upwards?
Downwards.
Downwards. Okay. FG downwards. NG.
To
How
the
about
right.
NG? Going to the
NG.
right. What else?
FAB.
B. Roughly here. I assume it has tension as usual. Okay. Remember the FFG here is already known from the previous three-body diagram. The one that is still unknown is this. Sorry. FCE is already known as well. Okay. FCE is already known as well from the previous one. So this one is already known as well. The one that is not yet known is this and this. So we have two unknowns. Okay, we have two unknowns and we have three equations. One of the equation we can use it. Okay, one of the equation we can use it to just check whether the calculation is correct or not. Okay, so we have this FAB and NG, two unknowns, this and this, and we have three equations: sigma fx equal to 0, sigma fy equal to 0, and sigma moment equal to 0. Okay, you can use two equations to solve for it, and the last equation to check whether the calculation is correct or not. Okay. Any question about this particular problem? Any question? Audrey Putri.
Yes, sir.
You understand?
Yes, sir.
Okay, good. Audrey Vanita.
Yes, sir.
Do you understand?
Yes, also.
Okay. Marsha, how about you, Marsha? Can you catch up, Marsha? Okay. Okay, I think I will try to discuss another problem. Then, this one is quite interesting as well. Let's discuss about this. This one is a lamp. Okay, lamp mechanism. Okay, and it rely on the joint friction. So it is known that at C here, there is a friction. At C there is a friction. But the other joint, okay, the other joint has no friction. So the friction will only happen at C only. Okay, it is known that the mass of the lamp is 0.6 kilogram with COG at G. Okay, the one in question is spring force here, Fs necessary for the equilibrium in the position shown. Fauzan, just now I asked you to do the previous problem, right? Would you mind to point somebody else to help me to do this particular problem? Hello, Fauzan? Hello, Fauzan? Fauzan is not there. Raka Wicaksono. Halo Raka. Saya minta bantuan kamu untuk mengerjakan ini, Raka.
Ya, Pak.
Oke, sudah paham dengan masalahnya kan ya, Raka? Ini ada gesekan besar di sini. Kemudian yang lainnya, pin-pin lainnya tidak ada gesekan. Lalu yang ditanyakan adalah gaya yang bekerja, gaya yang ada di spring AE itu. Oke. Seperti biasa kita mulai dulu dengan identifikasi batang dua gaya. Oke, kita mulai dulu dengan identifikasi batang dua gaya. Batang dua gaya yang ada di sini ada di mana saja ya?
BD, Pak.
BD, oke, itu batang dua gaya tuh. Ada lagi?
CD juga ya, Pak.
CD, CB, itu hati-hati ya di sana ya. Ini untuk kalian semua ya. CD, CD dan juga BC itu agak hati-hati ya. Please be careful at BC and CD because it is known from the problem that C here is pin with friction. Pin with friction. Remember that I told you guys that two force member is happening when both ends are pins, but there is no friction there. So BD is two force member, correct? But BC and DC is actually not two force member. BC dan DC itu bukan two force member, Raka. Oke, karena C itu kan ada gesekan ya di sana ya, Raka. Halo?
Iya, Pak.
Jadi BC dan DC itu bukan batang dua gaya. Ada dua lagi sebenarnya batang dua gaya. Coba dilihat sisi lainnya deh.
Batang AB, Pak.
AB betul sekali. Batang AB adalah batang dua gaya. Satu lagi. Walaupun ini bukan batang ya sebenarnya, tetapi pair ya, spring. AE itu juga dua gaya ya. Karena searah dengan arah springnya. Betul ya, pakai.
Iya, betul, Pak.
Jadi yang bisa kita anggap sebagai dua gaya itu adalah AE, AB, BD. Itu saja, tiga itu saja. Yang lainnya itu bukan batang dua gaya. Oke. Nah, sekarang untuk menyelesaikan permasalahannya, bagaimana ini enaknya, Raka? Kita mulai dari mana? Yang ditanyakan itu adalah gaya di pair ya. Gaya di pair.
Batang FD ya, Pak?
Kita mulai dari FD.
Iya, menurut
Coba
saya.
ya, kita mulai dari FD. FD itu adalah bagian yang harusnya kita selesaikan ya. Di F itu ada pin ya. Kalau pin ada FX, FY ya berarti ya.
Iya, Pak.
Lalu di E itu ada spring kan. Kita anggap dia tarik. Batang dua gaya juga. Ini ada FAE. Lalu di D itu ada DXD ya, betul ya? Berapa anons dari situ, Raka? Dari free body diagram itu ada berapa anons ya, Raka?
Semuanya unknown, Pak.
Ya, semuanya anons, ada 5. Kita tidak bisa nyelesain kan berarti?
Iya, Pak.
Oke. Yang diketahui itu baru dari sisi massa saja ya, 0,6 kg. Yang diketahui itu sisi yang kanan ini kan ya? Raka. Jadi kita harusnya coba mulai menyelesaikan dari yang diketahui terlebih dahulu. Nah, untuk bisa menyelesaikan batang FD ya, untuk bisa menyelesaikan batang FD itu kan di sana ada 3 kita cuma bisa menyelesaikan 3 anons ya. Berarti paling tidak kita harus menyelesaikan terlebih dahulu dari free body diagram yang lain 2 anons di sana ya, supaya sisanya tinggal 3, betul nggak Raka?
Betul, Pak.
Nah, DXDY itu bisa kita selesaikan dari diagram beda bebas sebelah kan? Bisa kan ya? Yang lainnya tidak bisa, tapi DXDY bisa kan? Halo, Raka? Halo.
Yes, sir.
Ya, jadi DXDY itu bisa kita selesaikan dari diagram beda bebas sebelah. Nah, untuk bisa menyelesaikan DXDY, ini kita bisa menggambar ini kan? Sistem ini kan ya? Jadi
Iya,
ada
betul.
BD, BC, DC sekaligus sama si lampunya. Jadi ini. Tujuannya apa? Tujuannya untuk menyelesaikan DXDY. Betul nggak? Ya, itu ya Raka ya. Nah,
Iya.
kita coba gambar sekarang. Kita coba gambar si lampunya. Saya gambar agak kecil aja ya. Oke, gaya-gaya apa saja yang terjadi di situ? Harusnya ada DXDY ya.
Iya, itu, Pak.
DXDY,
Terus berat masanya.
saya buat di atas saja deh. Terus DX-nya ke kiri. Ini DY-nya saya pindah di sini ke bawah. Oke, DXDY ke kiri ke atas. Setelah itu ada berat di sini. Berapa beratnya? 0,6 kg ya. Harusnya pakai G9,81, tapi saya pakai 10 aja dulu di sini. Jadi 6 Newton ya. Oke, apa lagi Raka?
BXBY, Pak.
BXPY, yakin BXPY. Coba lihat lagi, AB itu batang apa itu AB? Hati-hati loh.
Oh, 2 force ya, Pak.
Nah, AB itu kan batang 2G, tadi kamu yang ngomong sendiri kan?
Iya, berarti
Nah.
FAB, Pak.
FAB. Berarti FAB ya. Ini saya ganti dengan gaya 1, FAB. Nah, coba dilihat di situ. Anonsnya ada berapa?
Tiga, Pak.
Ada 3. Kita punya 3 persamaan juga di sana ya. Sigma Fx sama dengan 0, sigma Fy sama dengan 0, dan juga sigma momen sama dengan 0. Bisa diselesaikan tidak?
Bisa, Pak.
Bisa. Ini kita bisa selesaikan. Oke. Nah, setelah kita menyelesaikan itu, di XDY kita dapatkan kan ya? Bisa kita pindahkan ke sini kan ya? Bisa kita pindahkan ke diagram beda bebas dari batang FD kan? Betul kan? Nah, dari situ
Iya.
bisa tidak kita cari FAE? Halo, Raka?
Iya, bisa, Pak.
Ya, jadi seperti itu ya. Selesaikan FAB dx, dy dari diagram benda bebas pertama si lampu itu, kemudian dx, dy yang sudah selesai, yang sudah kita dapatkan, kita gunakan di diagram benda bebas kedua dari diagram benda bebas batang FD. Nah, nilainya sudah kita tahu. Jadi sekarang sisanya kita hanya punya 1, 2, 3 unknowns. 3 unknowns, 3 persamaan kita bisa selesaikan. Gitu ya, Raka ya? Oke.
Iya, Pak.
Untuk yang lain, apakah ada pertanyaan? Is there any question from the others?
Permisi,
Is there any
Pak.
question? Ya.
Mungkin saya mau tanya dulu, Pak.
Hmm.
Jadi itu kan kita pakai free body diagram dari si lampunya dulu ya, Pak. Nah, dalam hal ini berarti kita juga bisa pakai section untuk memotong AB sama FD gitu di sini ya, Pak.
Section AB sama FD.
Iya, dipotong
coret.
gitu, Pak.
Coba kamu coret-coret.
Ya, sebentar.
Gimana? Oh, di situ. Lah, coret apa namanya? Kita tuh bisa pakai metode potongan itu hanya pada batang 2 gaya. Kalau batang apa namanya? Batang multi gaya kita tidak bisa menggunakan metode potongan. Yang saya lakukan tadi itu bukan metode potongan ya. Yang saya lakukan tadi itu memisahkan. Kebayang nggak, Raka?
Oh iya, Pak, kebayang.
Jadi saat kita apa namanya? menggunakan untuk kasus frame ya, itu kita tidak bisa pakai metode potongan biasanya. Kecenderungannya tidak bisa karena banyak sekali batang-batang non 2 gaya di sana. Nah, potongan itu hanya bisa dikenakan di apa namanya? Di batang-batang 2 gaya saja. Oke, jadi kita tidak bisa pakai metode potongan. Yang bisa kita lakukan itu adalah kita menyelesaikan free body diagram satu persatu. Setiap free body diagram itu ada 3 unknowns di sana yang bisa kita selesaikan. Nah, kamu benar tadi. Oh, kamu coba lihat dulu yang FD. Oke, bagus itu. Kenapa tujuannya? Tujuannya supaya tahu kasus di tempat yang kita bisa mendapatkan FAE itu kan adalah batang FD. Jadi kita akhirnya nanti pasti akan ke batang FD. Nah, dari situ kita tahu bahwa unknowns-nya ada 5. Kita tidak bisa menyelesaikan kelima unknowns tersebut langsung. Selesaikan dulu 2 dengan free body diagram yang lain. Sehingga nanti setelah dikembalikan ke free body diagram batang FD, kita bisa selesai menyelesaikan 3 unknowns seperti itu. Kebayang ya, Raka?
Kebayang, Pak. Terima kasih, Pak.
Sip. Any other question for this particular problem? Fauzan, do you understand?
Understood, sir.
Okay, good. Oh, this one is for your homework. Later, I will ask you to do this for your homework. Okay. This will be part of your homework. Then for today, I think the last problem that I will discuss today is this one. This is a machine problem that is quite interesting to be able to, it's quite interesting. And I believe you can solve it. But this one is actually quite similar to the problem that we already discussed before from your homework. Okay, it's quite similar to this. Okay, it's quite similar to this, even though this one is more complicated. Okay, this one is more complicated, but still can try. Okay, in order to solve this, okay, as usual, right? The one in question is force at pin A. Okay, yeah, force at pin A and force at pin D. Okay, that is the one in question. Force at pin A and force at pin D. Okay, but in order to solve that, we have to know first which one of it that is two force member. Okay, wait a minute. William Nathan. Hello, William. Hello, William. Where is William? Ali Riyadi Narendra. Hello, Ali Riyadi.
Yes, hello, sir.
Okay. I need your help to determine which of this member is two force member.
Is F and G two force members?
Sorry,
F and G.
F and G.
Yes. Yes.
Two force member F and G.
Oh no, sorry. D and F, D and E.
D and E. Okay, that's two force member. What else?
C and B.
Yeah, BC. Okay, those two are two force member. So we have to treat those two as a two force member. Okay. The one in question is this pin and this pin. So which one of it that we're supposed to solve first? Ali Riyadi. Which of the system here that we're supposed to solve first? Ali Riyadi.
Be from G and F, sir.
Sorry?
Maybe we isolate G and F.
Isolate D, F.
G, F.
D, F.
Yes.
D, F. G, F or D, F? D, F. This one you mean?
Yes.
Okay. The problem with that one, there are so many unknowns that we're supposed to solve there. At A, there will be AX, AY. At F, there will be FX, AY. At D, there will be FDE, right? And at C, there will be FBC because it's two force members. So in total, we will have 6 unknowns there. So it's quite impossible actually to solve that. Why don't you try the way like what I did before? It is always simpler to try to solve the one, the free body diagram with known value. The known value that we have here is what? Ali Riyadi.
The weight of the lug, sir.
The weight of the lug. So the multi-force member that is directly connected to that is which one?
DE, sir.
Huh?
Sorry, FG.
EFG, okay. So we can try to solve for that one first. Okay. Okay, so that one. Sorry for the drawing. So we will have there the weight there 4800 lbf. What else that we have there? Ali ready?
Pardon me, sir. What was your question?
What else? What other forces that we have there? Remember here we have F and E, right? Pin at F and E.
Oh, yes. The tension from the two force members, sir?
So, okay, so this one FDE, you mean, right?
Yes.
FDE. What else?
And the FA.
Sorry.
The FA, sir, the balancing.
The balance. What do you mean by the balance?
I mean the rod FA. Does it count?
FA. Oh no, FA is not two force member.
Oh yeah.
FA is not a force member. You told me, right? The two force members.
Yes, yes, yes.
So FA
Is
is
that-
not a force member because FA is not a force member. At pin F, we have to include both forces, right?
Okay.
Yeah. So there will be Fy and Fx. Okay, but because the angle is 90 degrees over there, so maybe this one, the angle here is 90 degrees, right? So maybe it will be simpler if we use Fx and Fy like this. And it is allowed. So this is our Fy, and this is our Fx. Okay. Fx and Fy, as long as it's perpendicular to each other, is supposed to be okay. Okay. Then how many unknowns that we have here?
Only 3, sir.
Only 3. Okay. We
Yes.
have FDE, Fy, Fx. And how
Yes.
many equations? How many equations that we have?
We have 3 equations as well, sir.
We have 3 equations as well, so we can solve it. FDE,
Yes.
Fy, Fx. Okay.
Yes.
So this one we can solve it. We can solve it. We can solve it. Okay. Then after that, after we solve for that, which free body diagram that we're supposed to go for?
FA, sir. So we could
FA,
find
correct. We
CB.
can go to the main problem. So now, this one we have D here. Okay, what forces that we have there?
We have C.
Hmm?
The CB.
Sorry.
C, the joint C.
Okay, FBC then, right there.
Yes, FBC.
FBC. What else?
FDE.
FDE. We already know the value.
Yes, AX and AY.
Supposed to be
sir.
action and reaction with this one. Okay, FDE. What else?
AX and AY.
AX, AY. As usual, I will use this. AX, AY. Then Fx and Fy as well, right? Supposed to be action and reaction with this one.
Oh, yes, yes. Sir.
Fx, sorry, Fy, this one. Okay. So this one is already known, this one is already known, this one is already known. How many unknowns that we have here?
Still 3 unknowns, sir.
3 unknowns, and we can solve it right now, right? Previously we
Yes.
cannot, but now we can, right?
Yes, sir.
Okay. Do you get it? How to solve this? It's supposed to be okay, right? Okay. Any question about this particular problem? Okay, later I will give you some homework, and from those homework you can practice more. This is some other example here about a piston, friction in the piston, like that. Okay, I'm not sure, maybe this will be part of your homework as well. And tomorrow we will continue with the frame, with discussion on the frame. And unfortunately for us, we are lacking 2 hours in comparison to the other classes. Okay, because there is one holiday where it's only happening to us, and beside that, based on the topics that is already been covered by the other classes, I can see there that we are lacking 2 hours. So most likely, we will still need to do replacement classes to catch up with the others. And I will let you guys know. Wait a minute, have we picked class leader for this particular class? Hello, hello. Do we have class leader here? Aurelia Zadira. Hello, Aurelia.
Yes, sir.
I forgot. Have we picked class leader before?
Yes, sir. It's me. Reinhard.
Wait. Reinhard, right? Okay, Reinhard. I believe I know your number, right? Reinhard.
Yes, you have already.
Yeah, okay. So about the replacement class, I believe I will discuss it with you, okay, Reinhard? And before I will try to check with my schedule, and after I check with my schedule, then I will let you know the availability time, and try to discuss it with your friend about which one that is best for you guys. Okay.
Okay.
I think that's all for today. Thank you very much for coming. See you again tomorrow. And for tomorrow class, I think I will just use the class until 8 in the morning, because like it or not, we still have to do replacement class. Okay, I think that's all. Thank you very much. Bye. See you tomorrow.
Thank you, sir.
Thank you, sir.
Bye.
Thank you, sir.
Thank you.